Today, as scheduled, in class, we're talking about cryptographies. As I said, so we want to cover cryptographies that requires a little bit of hands-ons. And next week and week after that, we are not going to meet. What that means is that next week, asynchronous online, and then the week of our final exam, there's an online exam. Open book, open test. Okay, as far as you turn on your camera, I want you to turn on your camera so that I want to make sure only you guys do not see each other. That's it, okay? No other reasons. If it is online, then it's likely they can send some of the solutions to friends, and that's quite possible, right? Online. So I want to prevent that unacceptable behaviors.
So today would be the last in-person.
Last in-person meetings, yeah.
And the last homework is being posted too?
Correct.
Okay.
Yeah. Oh, because you're talking about the homeworks. Homework number 5. If you, I know not all of you submitted. If you didn't submit it yet, please do so, because I didn't grade it. Once I graded it, then your submission will be late submission. Still okay, because I didn't open it. Next few days, if you can catch up not any missing points, that homework number 5. All others I already graded. Still, if you want to gain partial credit, you can still possible to submit it. Right. Okay, that is that's about the homework. Homework number 6, that will be the final homework related to today's hands-on. It'll be a little bit of exciting, okay? So I hope you'll like it. As I said, next week, you stay home. Don't come. Read my posting. It does not require any extra explanations or hands-ons, only simply reading it. If there is any questions from your final exam, you can open up and take a look at. Final exam is open book and online. Open book and online. Your final exam will be can be found on this blackboard. Types of final exam is very similar to the exam types of your midterm, but you can see that electronically on your blackboard. And your answer is not by paper and pencil, but writing some, on text box. Okay, I think that is clear because you guys already have your midterm exams. And also, I think I posted here code practice, which can be done on your Colab. Raise your hand if you haven't done no experience on colab.research.google.com. So we will do that. Yeah, right. We will do that together. Yeah. But we're going to post that. You can download this, and then you can post that on that website. Google provides strong Python workstations. If you make, for example, lots of repetitions for machine learning, like 20 million iterations with lots of data, then almost impossible to run any kinds of laptop. And also it may require GPUs. Not many students has GPU enabled laptops, right? But Google provides that online, which is very, very powerful. We're not going to do that today, but once you get on this colab.research.google.com, our hands-on lab today is simply encryption. Encryption does not take much computing power. But once you get in how to use it, you can further in some other classes. Or if you do that personally, anything about machine learning, then you can come back and work on this, okay? So I'll guide you how to use it. Too many of you, this is the first time that you can work on the Google products for coding. This is very, very nice. Okay, so broadly, let's start with some of the slides that I prepared for today. We're looking at hash code and encapsulation, how we can generate the hash code, okay? Hash code is a basic tool that you can do for cryptographic exercises. Input could be very long, or could be very many different values, but output is only one. That is called the hash values. Okay. In another pictorial explanation, it looks like this. If you have a hash function, h of d, d is a data, you have a multiple data, but you have a very small numbers. Like if you want to make a hash code for your entire file system, hard drive, then it can give you one hash code. It could be 160, whatever the size of that hash code functions. If it gives you 128 bits sized code, then you can make it. Or 64-bit size, or 512-bit size. You will be able to see that, okay, on our exercise. Underlying concept generating hash code is from mathematically hash function. What is hash function? Hash function is a mapping from data to another data. Another data means output data in fixed size. Input data, flexible. Any size of the data, input data. Like your hard disk drive, okay, 1 terabytes big. But the output, depending upon the function, if you are using a little bit expensive hash functions, then it can return to you 512-bit long hash code, which is almost unique. So if you have hash code generated from your, for example, file system, to prove genuinity of your hard drive, then you can generate later another hash code, compare those two hash code. If they are exactly the same, then you can say, oh, they are the same. If any single bit is changed from your hard drive, then the hash code that you can receive is completely different. It's not like one bit tweaked, completely different code. Okay, so that is the hash code. It can be mathematically from modulus. What is a modulus? Modulus is the remainder, right? So 17 divided by 3, what is the remainder? 17 can be divided by 3, so quotient is 5, and remainder is 2, right? 2 is a remainder. We are talking about remainder only. For any size of the input data, we divide some prime number, and our the number that we are interested in is remainder. So remainder is always depending upon this divider, right? If divider is 3, then remainder is 0, 1, or 2. Do you see here? 17 divided by 3, then remainder is usually 0, or 1, or 2. So a little bit of two things. Almost a fixed size, number one. Number two, small, right? That is underlying concept of hash code. So hash code can be, it's a modulus by 3, modulus by 2 to the power n. Usually we use this number prime. Okay, very, very, very high prime number. So that hash code that you can generate, even if that is randomly defined, almost impossible to be the same. So we looked at that. Hash. So your passcode can be changed to some hash code. Anything that you put there, it could be hash code. So if you want to save your password, safely, that is, you can pass through hash functions. Usually we import a hash library, as you can see here. So this is the plain text, and then from this Python module, there may be some of the methods available. The method that you can use is MD5. So MD5 takes these strings. Usually MD5 takes strings. It does not take plain text, but it takes byte code. Some of the byte code. How can we get, how can you convert this to byte code? It is simple. You can do dot encode. Okay. That is a result. If you want to get hexadecimal value from this MD5 code, then to this result, you can invoke the function called hex digest. Then you can print the hash values for this plain text in hex code. That is typical hash code numbers. Hash code that you can generate, then you can see the hexadecimal code. like this, through this path, that those steps that you can get hash code. We can practice this later. Okay, so with the hash function at hash code, the concept that we learned, then we can think of the encryption and decryption. As I explained multiple times, not particularly this separate modules, course module, but there's a symmetric and asymmetric encryption. This is a symmetric encryption. This plain text can be converted to cipher text using a key, left side of this. Then you will get a cipher text. It's not readable, right? It's not understandable. So key is used for that encryption. The very same key can be used to decrypt. Like the key that we use our daily life, your home door key, you lock it up by using the key, and you can unlock by the same key, right? Your automobile, same thing. Anything that we do here. It sounds like then there may be another kinds of encryption, so-called the asymmetric key. Two keys may be needed. One key to encrypt, then the other key can be used for decrypt. It's not arbitrarily any two keys, but those two keys are paired. Can be generated from the same mechanism. So having one key, then there will be a corresponding the other key available. So two keys may be generated, asymmetric. So let's start with the symmetric key. Explained in this way, the same key will be used for encryption and decryption as well. This slide explains more about encryptions, not only symmetric key encryptions. There are two types of keys, public key, crypto. If you have a public key, then correspondingly there is a private key. Generate public key, then the other part will be the private key. They are paired. So pair of keys. Public key for encryption, then private key for decryption. You can use the other ways, many cases. It's not simply, private key only used for encryption. No. Symmetric key, same shared keys for both encryption and decryption. Algorithms, there are lots of algorithms available. But basically, two algorithms or more algorithms, maybe two, block cipher. So data is given, so you apply your algorithm to that block of data, which is a little bit simpler than stream cipher. Data is not given. data keep coming and going out. Still, we want to encrypt it. Is it possible? Yes, it has been developed, and currently, knowingly, unknowingly, always used. From your cell phone, if you send out some of the data, automatically encrypted it. The recipient do not have the key, the same key that your phone, although you do not know whether there is a key availability, but anyway, it is, if it is assumingly if it is encrypted, then key may be used, but recipient does not receive the keys, right? And recipient of your smartphone is not only one. There are tons of other arbitrarily many, right? How come they know? Okay, basically what they do is, before they communicate, actually you don't notice, but when you try to send, then before data is shipped out, they need to communicate and shake hands. And they said, okay, let's start to generate the keys. So sharing only one time of data, if it is hacked by, if it is interrupted, that's okay, because it is not a key. Based upon that, they can generate the keys at one side, maybe private key, another side, the public keys, send out by encryptions, and then recipient receives this, and then decrypt it very, very quickly, right? Understanding, we have to follow step by step, so it takes longer and longer in mathematics, but in real implementation, it's so quick. Streaming cipher. Partition text into small blocks. Encode each block depends on the previous blocks, and different key is generated for each block. So key is generated, and therefore it can be used for encryption and can be used for decryptions. Okay, let's first see the symmetric encryption. We generate the key. So in this case, we download the module fornet. So we have to see what is fornet, right? So fornet has generate keys. So let's start here, fornet. And we need to say here Python. Then symmetric encryption. Generate own key with the Python fornet. And fornet, I think I collected this once. So let's take a look. This and that looks similar, but let's take a look at this. Then method used. Method used, generate key. This method generates a new fornet key. Then what is fornet? Cryptography is the practice of securing useful information while transmitting from one computer to another or storing data on a computer. Cryptography deals with the encryption of a plain text into ciphertext and decrypt ciphertext into plain text. Python supports a cryptography packages that helps us encrypt and decrypt data. The fornet module of the cryptography package has inbuilt function for the generation of the key. Encryption of plain text into ciphertext and decryption of the ciphertext into plain text. So you can do three things, right? Generate the key, encryption and decryption. Generate the key, decryption and encryptions. So code here, so import from cryptography.fornet packages, and this, by invoking this method, key is generated and we assign that to key, variable key. So key is a key. And then we make an object of fornet by using this key. And that F is a fornet object. So this fornet object can encrypt, fornet object can decrypt. Okay, F.encrypt, F.decrypt. Okay. Makes sense, right? It's so simple. So we practice this. So a little further. Asymmetric encryption and decryption. I want you to look at here, the bottom, the key generation. Both keys are not the same, but they are the pair. So public key and private key. This is not arbitrary public key. This is not arbitrary public keys, right? They are generated from one module. So using public key, encrypt the plain text. Then we will obtain ciphertext. And you can share this ciphertext with your friends. Along the way of transmitting that ciphertext, even if it is compromised, even if it is taken by someone else, okay. That person cannot decrypt this. Only the person who has, remember that I have one part and the other part, right? I think I explained that, did I explain how it looks like? By using,
With the paper.
yeah, paper, yeah, it looks like that, right? So the other private key is not just private, it's not just any other private key. That is the private key for that public keys. So only those who holds this private key can decrypt it. Okay? This is nice, right? One of the implementation is called RSA encryptions. This is initial from three scientists. I used to know their name. I think one Rebbe, I think two of those guys are from, they developed when they were in MIT, so faculty members, and then they they created their own company, RSA company, and there is a RSA annual conference. It is very, very hot. They brings thousands of participants every year. So anyway, that is RSA. Install. So for using this RSA, we're going to use this package, Pi Crypto DOM package. Pi Crypto DOM packages. So once we download this package, then we need to generate RSA key pair and get the public key and private key and let the public key to encrypt let the public key encrypt a message, and let the key, assumingly the private key, but we use the key, decrypt the encrypted ciphertext. Excuse me. So the code is like this. Okay. I need to save this. All right. So are you guys ready for collab at Google? I want you to open up one web browser and call collab.research.google.com. Yours is not, because you are the first time access this website, may ask you to, yours is a little different, right? But anyway, follow the guidelines. If it asks you to register, please do so. I think you can start if you have a Google account.
Start at 2. It wouldn't end. Yeah. But the best views you could get actually is on that side. But if you leave the windows open, there's all of the provisions buttons that are on that side, and then it just syncs perfectly. It's great.
Are you ready?
Yeah.
Oh, ready? Oh, good. What can you see right now? Oh, okay. And here's what you need to do. I think I want to close this. Can you see here file? Oops. File. You can see it the right side over there. Click on the file, then there is a upload notebook. Third options on that menu, upload the notebook. Click, then browse. By the way, did you download the code that I posted on the Blackboard? You can first download it on your local system, and then upload that file to this. So I am going to use this. So do you have the file like that? Lab 1 data encryption and decryption?
Yes.
Okay. This is really, really good. I'm going to explain this, the collab, to you first. There's a code and text. see, this is the code. If you scroll down, then there is the text. There is some text, right? And then all of a sudden there is a code. And then text and images, and then code. We can mix that. Okay. So, for example, somewhere there, if you place your mouse a little bit, I'm now placing my mouse a little bit over the part 1 getting ready. Then you can see plus code and plus text small button on center. Do you guys have this? So if you click code, then you will get the code. Same thing, if you have back here, if you make text, then you can get the text. If you have text, then here is my text. And if you click another space, then it'll appear the text. This is the text that I made. Code, you can type anywhere that you can code. For example, print. I like this Google Colab. And then if you bring your mouse on that region, then on the left end of that the code block, there is a triangle. Usually that triangle is the button to run the code, right? So if you click this, then the code can run. So there is output. You can code whatever you want to by creating code block. If you want to explain about that code block, you can click on text button. Always it can be created one before. If you click here for that, then it'll be created one before. One above, I would say one above, okay, one before that block. So this is my previous block. I have another block over there, right? You can make multiple lines in one block, or maybe single statements per block. Very, very flexible way you can make, okay? If you want to see this very nice introduction of this, then you can click somewhere here. This is the entire one data block. Then on the upper right corner, there is some buttons. I want you to click pencil button. Click on the button. It is said edit. If you click this pencil, then you can edit it. If you click it, then you can see this is something I like. Automatically can be divided into two pane, left pane and right pane. Right pane is exactly the way that you can see. Left side, that is a little bit of like a markup language, like HTML. Some HTML works, but not all. For example, here BR, that's HTML, right? For pointer or link, it's not the same as HTML. A little different. Here, square bracket inside, then this is clickable text, followed by within parentheses # P1, and therefore the other side somewhere you need to have the point that you can bring user's attention from there. So let me explain that. Remember that here, getting ready, this is clickable. Getting ready, that is clickable. Go back here. Remember that getting ready, that is clickable, like this. This is not shown. This is, I think this is a label. This label is it's like anchor in HTML. It gives you, it points to, it jumps to that label directly. So if you click other place, then you can see it. So if I click this, and it goes to more dynamically. If I click part 4 here, asymmetric encryption, it jumped to that part 4 because I have that codings. If I click this, see here part 4. Going back, you have to scroll back. All others, I don't know much, but only the minimum that I want to make this. Okay, so you can read. This is a lab for data encryption and decryption, and this lab helps you understand how data can be encrypted and decrypted. Lab structure part 1, you can jump to part 1, but before you click on this, I want you to read these things. The following modules needs to be imported. So all of these modules needs to be imported. So first we have to import to run the rest of this code. So click this, getting ready, then it jumped to that part 1. And then I explained some. This is something that I made, right? This is not something related to this lecture. If you want to remove this, then click on that. On the upper left corner, there is a trash can. If you click that trash can, then that block will go away like this. But anyway, when you come here, I imported many. I want you to note here, PyCryptoDome is not available here collab. So we have to explicitly install it. The way that you install is exclamation pip install. By the way, raise your hand if you didn't take Python course. You guys all currently taking, right? Okay. Little bit of Python. I know you like Python. So in Python code, if you want to still install, then you can do exclamation mark pip. Then it goes out from that Python. What that means is you go to operating systems, hey, install this, and come back. Very simple. So this exclamation is good. So this guy can run all together. If you click that run button, click. So I think here install, this portion is installed. So installation is done. And all others import silently. Okay. If I want to make here go back button or top button, I didn't make it. You can do that and go back to the top. Okay, so we have 3 modules, part 2, part 3, and 4. Part 2 for hash code, part 3 symmetric encryption, part 4 asymmetric encryption. Okay, the one that we learned from slide. So let's jump to hash code. Before we do that, here using random number generations, we can make a hash code. We're using MD5, we're using SHA. MD5 and SHA. MD5 is a little simpler hash code. SHA is a longer size of a hash code. SHA has many different versions, so more dynamic. So click on the hash code to part 2. This data block starts with the images that you can see on our slide, the same image that I posted. And then number 1 here, using random number. So if you could click, then you can generate. This hash code is from this modulus.
The number in random get it's 128. Can you change that to?
Oh yeah.
56?
Mm-hmm.
Yeah.
Try anything that you want. This is something that you can practice. If you some other code block, I'm going to explain that. But if you make it really big number, then it takes longer and longer and longer. I tried, but it takes several hours, even on the Colab, Google Colab. So, but here you can quit it very quickly. That is one thing good. If you accidentally make your code to be iterated a million times or 100 million times, so that it goes longer and longer, if you want to interrupt it and restart, some of the hassles, right?
So this code is like not it's compiling on a Google server or something? It's not compiling on the computer?
No, Python is not compiling, it's interpreting, quick interpretations. So you can restart quickly here in Colab. If you have a separate application run on your laptop, then it has some. It may create some issues on your laptop, but here has nothing to do with your laptop, but the Google. But powerful, and handy. As far as you have internet connections, Google Colab works better than my laptop, at least. Later, if you want to work on the big size of data to train for your machine learning, not only the size of data, but iterations. Without running on Google Colab, in my case, almost impossible to run. Okay, so you can practice by clicking. Next one is Another case, random. We can make random bits. This is nothing about just a random numbers. And then third code block, we want to make real hash code for some plain text. So this is a code. We import the string separately. Here, you can import all together up front, or you can still import at any point necessarily, like this. And then dot join function. This is a little bit of not well understood in your case, but I want to see if this is another way that you can generate. You can change this. You can generate the hash code like this. This is some of the hash code, but you can generate more. Mercy University cyber security program. Still the size of this hash code is the same, as I said, the fixed size. So I would put this here. This is the previously Mercy Cyber, Mercy University. This is for and then I can run this. Then this is for Mercy University cyber program. Okay. This is exactly the output. The size of output always the same if you run the same programs. If you change it, the data only, but still the same size, same in size. Output always the same in size. Okay, you can make any comment on your code. This is very nice, right? So far this is using random number, and then now we can use MD5 digest, another module, MD5. So we can make a plain text, say Mercy University, and let's say if you want to run this simply like this, only plain text, see what happens. It says strings must be encoded for hashing. Why? Because this MD5 expects a byte code. To make a byte code, what we need to do is that plain text needs to be encoded. So dot encode, open and close parenthesis, and run, then nicely can run, right? Again, if you want to simply plain result, see what happens. If you make I want to print whatever returned from hash library.md5 execution, I want to print that result, then that result is this. Simply hash objects. This is a hash object. If you want to get the value from this hash object, then you need to have a dot hash digest functions. So you can make a comment here, or you can say simply here returns a hash object. Finally, if you want to see the SHA, there are many different versions of SHA. SHA 256. Let's say this is SHA 256. And then there is another hash library, and see there's a SHA 224, many different versions. SHA 256, SHA 384, SHA 3 underscore 224, SHA 512. Okay. So SHA 512. And then we can say this is a SHA 512. SHA 512. And then I want to make I want to first use it 256. So that is 256, and print that, and then also 256. This is a byte code. If you say B start with the string. If you do not have this, then what you need to do is, to the end, you have to say dot encode. One over the other. Okay? To make a byte code. So if you want to make that notes, then you can simply say to then you can do number one use the prefix B. Plain text, or invoke a function called encode. Okay. So you can use the encode like this to generate the same answer. Or if you do not want to do this encode, then simply prefix B and run. Same thing, right? So this is what I'm saying here. Oops. And also if you want to this make yeah, italic, you can make italic like this. B. Okay. Now for to make it more difficult to encode or decode, then you can make a copy of that. And instead of 256, you can do 512. 512 and 512 and 512. Okay, and run. Do you see here? Size is bigger. This is 256 size. 256 bits. Here doubled.
You can also use assault to make it safer and longer.
Oh yeah, yeah.
Yeah.
Assault, yeah.
Yeah.
You can do that, yeah.
It's especially strong against attackers
Mm-hmm.
that want to brute force a password or something like that, because if they don't use a table that already has a lot of solved keys that are used, they will never crack the password.
Yeah.
And what's fun about, well, fun, depends on what your definition of fun is.
Mm-hmm.
In that table, it's called a pre-computed table or a rainbow table, and it has all of those salts in them,
Mm-hmm.
and that's how people at least try to brute force passwords that have been encrypted.
Right.
And when there's very weak encryption, when it's only like a 128 or something like that, it's fairly easy. But with salts, it gets really hard.
Good comments.
There's actually Hack the Box. It's a website that basically teaches you a lot about information security, offensive security as well, and they have a really good like training course for anything that's encryption and cryptography, and that's what I did to learn cryptography.
Hmm.
Yeah, it's really good. It's even for beginners. It's super simple. It's very useful.
Very good. So you can expand this text box, code box bigger and bigger by trying. That is your asset. It is not my asset, right? All right, so this is the hash related issues that we looked at. Now, symmetric encryption, same image that we looked at, and same code that that I explained, using fornet and generate the key objects, and from that key object encrypt and decrypt. And again here, if you, I want to run first, very quickly. So by token here, that is encrypted token. So that is a cipher. This is a cipher, right? This is a byte code itself. But if you want to print that in hexacode, what should we do? You have to decrypt, decode. Decode this byte code, then it will be turned to hexacode. So with no B as a prefix in front. This is the token. Nicer because there is no B colon and quote and unquote. As I said, this is a text. If you want to, another way that you can make a byte code is to start with the B as a prefix that I explained it here. Uh, Finally, asymmetric encryption. Basically, 3 steps are needed. Generate the key pair, public key and private key, and then encrypt plain text by a key, either public or private key, and decrypt the cipher keys by other keys. Generate public and private keys first. Before you run this, I want you to click here. Check out this link. So I want to click. I want to open in a new Windows. Okay, RSA. Right here. To generate key pair, RSA.generates. 2048 is recommended, but you can increase 3072. But if you increase by multiplication by maybe 10, 100, different digit, different magnitude, then it takes much longer. So 2024 is recommended by this RSA. And some of the functions that we are using here, for example, generate public key, export key, and then there is a RSA modulus n, this modulus integer n, and I believe exponent. These two numbers are important, n and e. RSA modulus and RSA public exponent. The way that you can defining RSA keys, and then export key. Let's first take a look at, so we have an export key here. In order to get export key, then we have here n modulus. Modulus is a public key n, and then public exponent is public key e, echo. That's what this public key of RSA generated. Export key. So it's a public key. This is the function public key. A matching RSA public key. So returns new RSA key, RSA object. So this is not a key itself. This is an object. So public key, this is an object. So from these objects, you need to invoke key itself, then that key is a public key. So we call that public key PEM. Then you will be able to see this public keys. By running this 2048 random number generations, then you have a pub key. The real public key is here. So when I run this, so first here, public key modulus, big size of a modulus. What is a modulus? Remember that our my slide, 17 divided by 3, then 3 is a modulus. Then we know divide 3. What is a modulus? Then the remainder is modulus, right? Here, the code for modulus itself is real bigger number. The modulus 17 divided by 3, the modulus is number 2. Simple in concept understanding, right? Likely modulus here that big. Almost impossible to guess. And then public key itself, this is the first printout. So this is that printout. Second printout here, public key. Third printout, private key lately. Okay, so this is a public key by this. After that, we say private key, modulus, and exponents. From that, this is the same as this. It's public key, private key. Still the same modulus. Exponent is different. Here there is public key exponents. Here D. What is D? D here RSA private exponent. E is public exponent. D is private exponents. So we have a private exponents. It's private exponents here. Public exponent is simple. 10001. Private exponents complicated. So using this, we generate also private key. So private key can get from key pair here, key pair. From key pair, we can export the private key. That is a private key. So reading this, the manual is very, very important. If you see this manual, then we have a private key function, right? See, this is private key function, public key functions. But there is no private key functions. Do you see here? Export key, public key, but there is no private key. Private key can be obtained from the original key pairs. Public key can be obtained from private key can be obtained from the key pair by invoking public key function. Once we have that public key functions result, then we can export it. Then finally we'll get the public key. But private key is different. We do not generate public key objects like here. This is not available for private key. But we go back to original key pair, directly export it. Okay. Do you see the issue? If I say here, so we may explain here more. Oh, this is too big. I'm not going to explain it there. I think I am going to explain here. So public key obtained by invoking export key function on the public which is generated from key pair. By calling public key functions. And then we can say break and private key is, however, obtained by invoking export key function on the key pair directly. That is the thing. So private key obtained from this directly from that key generates, which is key pair. Private key, one more steps. So we invoke public key and then public key object. From the public key object, we can finally get public key code. Okay. All right. And then now we are ready to encrypt. So we have the messages and encrypt. Then we can do, we need to make a encryptor. From that PKCS1 underscore OAEP. Okay, this is the module. So I want you to get oh no, to have this. So So this is a little bit complicated PKCS. Um, here from same PY crypto dome, crypto.cipher, so that we import. Let me see the code that we have. All the way up, if you go there, then we import PKCS1 underscore OAEP from the package crypto.cipher. That's what we used, right? That is explained here. So if you want to make that on your text here, I want to make here check out this help. So what you need to do is href equals, and then that web page, and then you can say this API. Okay, so it goes there. So check out this API, then you will be able to see this PKCS #1 underscore OAEP libraries. So that goes there. Okay, so we use that function to run. So all the way down here for encryption. So we first generate public key objects for encryption. We call that encryptor objects. Once we generate that encryptor object, then we can encrypt it. The message, whatever message that we have, it should be in byte code, or we can do encode it. Then we encrypt it, and then that encryption can be displayed. If you want to display it, then we can use binary ASCII dot hexalify functions. That is this. So if I run this, if you do not have this, simply see what happens here. If you want to do print simply encrypted. If you want to encrypt it itself, then that is this. This is a byte code. So you want to make it nicely, then in hexacode, then you can do this. Or you can do, as we learned already, encrypt dot decode UTF codec cannot decrypt byte position for, yeah, that this is the reason we do not use decrypt. We simply borrowing another module, binary to ASC and hexa-like description. That's what we have. Then we will have this hexa-like description. Again, if you want to remove this B binary, then right now here you can say decode. Then you will have you can remove that one's a little nicer, right? That is encryption. This encryption, this is a cipher. If you send this data to somebody, right? If you send this data to somebody, then that person cannot decrypt it because that person does not have a private key. And private key itself is, what is the size of a private key? This is a private key. How come you can have that private keys, right? So almost impossible. Only rather than what happens? That monitor is off. Anything that I can see? That monitor, I think there's no power, right? Not only the signal.
I think they are powered on.
Powers. Oh, okay, came back. All right. Okay, finally. So how can we decrypt it? We need to have the key pair. Remember the key pair is that we used, right? Where did I say? Okay, private key is however obtained by invoking export key on the key pair directly. So key pair, we use a key pair directly, and then generate decryptor objects, and that decryptor object can decrypt it. So if I decrypt it, then I can see a message for encryption that can be decrypted it, right? So if I put here generates big noise, and then we can again encrypt it. So we have this encrypted cipher, and that one can be decrypted it. If we decrypted that, then we decrypt it very quickly, right? And message encryption, Manhattan City block generates a big noise that we had here. This is a different code blocks, right? But this sounds like this guy sent a cipher, and that encrypted can be decrypted here. All right, little bit of all the hash code there, all the coding list there, but understanding each line of codes requires some more understanding. But at this level, I want you to taste the way of the, the encryption and decryptions. Finally, what I want to do, how can we download this? So on file here, and then I say here download. The two ways that you can download. IPYNB. NB is a notebook. NB stands for notebook. Interactive Python notebook. Or you can download it simply PY file. Okay? So I will download this PYNB, and then I will post it again, so you will have two different versions of. This is it. So I would say here, after practice, what I will do, I am going to post that, so you can compare. This is the given, and then I am going to post another. After the exercise, then which one is it? Oh, download, right? Yeah, this. So my work is posted there. So you can see the work that I did, exact same ones. If you upload it, then you can see my work. You don't have to understand all. If you can understand all, it'll be really, really good for you. Other than that, the point that I can bring here in this class is there is some encryption techniques available. So we can do encryption by the same key or different keys, so that you can see how they are encrypted and decrypted. Okay, how you can see the different, how you can generate the keys if you have RSA algorithms in Python code. Coding list there. So yeah, any comments? Yeah, a little bit difficult too. The coding itself is not easy, right? But I wanted to understand the concept. Any comments? Any issue? Other than that, this is the end of interactive lecture.
What's the last homework gonna be like? Is it gonna be?
I want you to do something like this. Yeah, I want you to. I will make some blank, and you can fill in.
Okay.
You can see it quickly by clicking.
Yeah.
It'll be IPYNB, so you can work on and submit that once. You know how to upload, how to download,
Yeah,
right?
yeah,
As I showed to you.
Sounds good.
Okay. I'll see you sometimes. If you, I'm teaching usually the 455 for undergrads. Usually one course. Most courses for graduate. 455 is secure and intelligent programming. Because I'm coding guy, so I'm teaching the codings. Secure and intelligent programming. In that course, you can learn some virus, some malicious code, and detect malicious code, and something about intelligent codings, like machine learnings.
You said the graduate level course?
No, undergrad.
Oh, it is.
That is the undergraduate course that I am teaching.
Okay.
Yeah.
And the rest, you meant the rest of them are all gonna
Right, all others, yeah, graduate. Yeah. So hopefully see you guys maybe in